Imagine you're standing in a vast field at night, surrounded by millions of twinkling stars like tiny hanging lamps. That sky, though beautiful, is just a tiny corner of the vast cosmic painting. So if we had a magical ship that flies as fast as light from the sun to Earth, how long would it take us to explore everything? Just a question for scientists with whiteboards full of symbols, but also an endless inspiration for philosophers dreaming about life. It could be said, this is a journey of imagination, where we both explore and wonder how small humans are before the universe, and what we can do to overcome those limits. Let's start with a simple question. What is the speed of light? If you turn on a flashlight in the dark, the light from it rushes away so fast you can't see it moving. Science tells us that light in empty space, where there's no air, no dust, just endless void, moves at about 300,000 kilometers per second. To visualize, if you could run as fast as light, you'd circle the Earth nearly 8 times in the blink of an eye. Change, whether you This is the discovery that a great scientist Albert Einstein made over a century ago, and it completely changed how we think about the universe. Einstein said that the speed of light is like an unchangeable law of nature. Anything with mass like humans, spaceships, or even a tiny dust particle cannot reach the speed of light. Why is that? Imagine pushing a bicycle. At first it's easy, but the faster you push, the more strength you need. At some point, no matter how hard you try, the bike can't go any faster. With the speed of light, it's similar. When an object approaches that threshold, it needs an almost infinite amount of power to surpass it. Only things without mass, like light or radio waves, can rush at that maximum speed. But the wonder doesn't stop there. When you move fast, close to the speed of light, familiar things like time and space start to change strangely. Time can slow down, and the distance in front of you seems to shorten. Science fiction, it. Before thinking about exploring the universe, we need to understand how vast it is. Imagine holding a small ball in your hand, that's Earth. Now broaden your view. Our solar system, including the Sun, Earth, Mars, and other planets, is just a tiny dot in a huge neighborhood called the Milky Way galaxy. But even the Milky Way is just one of billions of other galaxies drifting in the vast universe. To measure distances in the universe, scientists use a unit called a light year. A light year is the distance light travels in 1 year, which is about 9.5 trillion kilometers. It sounds big, but in the universe, it's just a small step. For example, light from the sun takes only 8 minutes to reach Earth. But if you want to go to the nearest star outside the solar system, you need over 4 light years. Meaning over 4 years of traveling at light speed. Our Milky Way is about 100,000 light years wide from one end to the other. If you think that's big, look further. The observable universe has a diameter of about 93 billion light years. Why is it so large? Static, it. This means things far from us are getting farther away, even if we're standing still. Now think about exploring all these distances. If you fly from Earth to the edge of the Milky Way at light speed, it would take 100,000 years just one way. To cross the entire observable universe, you need at least 46.5 billion years. That's not accounting for the universe growing larger while you. If you've ever watched sci-fi movies, you might have heard about time slowing down when traveling fast. For example, you have a twin sibling, you board a super-fast spaceship. Fly near light speed to a distant star and return to Earth. When you come back, you're still young, but your sibling has aged a lot. Possibly decades have passed on Earth while you only felt a few months. This phenomenon is called time dilation, when you move extremely fast. time for you seems to run slower compared to those who stay behind. There's another strange thing. Space also changes. Suppose you fly a long distance, like from Earth to a star 100 light years away. For someone standing on Earth, that distance remains 100 light years. However, from inside your spacecraft traveling at a speed of light, that distance appears to shorten, possibly to just a few light years or less. This is the phenomenon of space contraction. These things may sound strange, but they have been experimentally verified. Scientists once placed ultra-precise clocks on fast-flying airplanes around, and upon return, those clocks ran a few millionths of a second slower than clocks on the ground. This is practical evidence showing that time and space are not fixed. They change when you move at high speeds. So what does this mean for space exploration? If you were an astronaut on a super-fast ship, you could traverse immense distances while only experiencing a few years of your own time. But for those left on Earth, hundreds or thousands of years may have passed. This is one of the great mysteries of the universe that we will explore further. Suppose you have a magical ship capable of flying at the speed of light, which science seems impossible for humans, but let's accept it for easier visualization. You want to travel from Earth to a star 100 light years away. What happens? From the perspective of those left on Earth, everything is simple. It takes you exactly 100 years to arrive. Because of the speed of light, each light year corresponds to 1 year of time. If you want to cross the Milky Way, which is 100,000 light years wide, it would take 100,000 years according to Earth's clock. But from your perspective, the astronaut on the ship, everything is completely different. Due to the space contraction effect, the distance of 100 light years can shrink significantly. Remember, your ship is flying near light speed. You might only feel the journey lasts a few years, or even months. When you arrive and return, you are still young, but Earth may have entered a completely new era, with hundreds of years having passed there. Let's take a more specific example. You travel to a star 10 light years away at near light speed. People on Earth would see you take 10 years to get there. But on the ship, thanks to time dilation and space contraction, you might only feel a few weeks or months have passed. They traveled a total of 20 light years, but you. This raises a big question. What is space exploration really? Is it traversing everywhere in a short time by your perception, or returning to tell the story to those left behind, who may no longer exist? Despite major limitations, humans never stop dreaming. Scientists and science fiction writers have devised bold ways to surpass the light speed barrier. One idea is warp drive, an engine that bends space. Instead of making the ship move faster than light, you contract the space in front and expand it behind, as if gliding through the universe without actually violating physical laws. Sounds like Star Trek, right? But scientists have actually studied this idea, though they say it requires an immense amount of energy, possibly more than a star's energy. Another idea is a space-time wormhole or wormhole. Imagine the universe as a sheet of paper. Instead of going from one end to the other, you fold the paper and pass through a hole to reach the destination directly. If wormholes exist, you could jump from Earth to a distant galaxy in an instant. But the problem is no one knows if wormholes are real, and if so, how to keep them stable for a ship to pass through. Looking to the future, space exploration may not rely solely on speed. Currently, we use telescopes to see billions of light years away, observing stars and galaxies without leaving Earth. In the future, robots and artificial intelligence could fly in our place, sending back information from distant places. But if humans truly want to go, we need major breakthroughs, new and more powerful energy sources, stronger materials to build ships, and ways to protect astronauts on long journeys. Perhaps one day, we'll find a way to warp space or traverse wormholes, turning science fiction dreams into reality. So, how long does it take to explore the universe at light speed? From Earth's perspective, the answer is simple. It takes as many years as the number of light years traveled. Traveling 100 light years takes 100 years. Traveling 1 billion light years takes 1. However, if you are on a spaceship, time can pass much faster due to the special effects of space-time. Thank you for watching this interesting video.